Good day, I am Monette Mabiling from 5203, and for this video I'm going to talk about retrofitting. Um, the retrofit process is a general or a process of it's a general term that may consist of a variety of treatments including the preservation, the rehabilitation, the restoration, and the reconstruction. So, selecting the appropriate treatment strategy is a great challenge involved in the retrofit process and must be determined individually for each project, depending on project objectives, preser- uh, preservation and renovation of buildings may involve an array of diverse technical considerations such as fire life safety, geotechnical hazards and remedies, weathering and water infiltration, structural performance under earthquake, and the wind loads. So, let's talk about preservation. So, preservation is defined as the process of applying measures to sustain the existing form, integrity, and materials of a historic property. Then, um, rehabilitation naman ay it refers to the process of creating new application for a property through repair, alteration, and additions while preserving those features which convey its historical, cultural, or architectural values. Then the next one or the third one is the restoration. Restoration is the process of accurately restoring a property as it existed at a particular period of time. Then the last one is the reconstruction. Reconstruction is described as the act of replicating a property at a specific period of time. There are some methods for retrofitting of concrete members, including the continuous fiber reinforced plate banding construction method. The banding continuous fiber reinforced plates to the surface of the existing structure to restore or improve load carrying capacity. Then the next one is the continuous fiber reinforced plate jacketing construction method. In this, jacketing with continuous fiber reinforced plates around periphery of the existing structure. This is to restore or improve the load carrying capacity and the deformation characteristics. Then the third one is the pre-stressed concrete jacketing construction method. It is placing pre-stressing wires and pre-stressing stranded steel wires in place of lateral ties around the periphery of existing member sections and using mortar and concrete to band them in order to reinforce the structure. The next is the pre-stressing introduction construction method. Using internal cables to or for the existing concrete members to provide pre-stressing and restore or improve the load carrying capacity of the members. Then for the last method in retrofitting concrete members is the repaving method. This replacing some of all the members of all the existing concrete members with new members through the use of the precast members. It is also concreting on site to restore or improve load carrying capacity of the structure. So, for retrofitting of structural body naman, The first method is the beam addition method. So what is beam addition method? It is adding beams between the main girders of the structure or the existing reinforced concrete deck to reduce the deck span and then restore or improve the load carrying capacity of the reinforced concrete deck. Then the second method is the seismic wall addition method. It is placing new reinforced concrete walls between existing reinforced concrete, rigid frame bridge or piers, and bonding them to form a continuous unit in order to restore or improve the load carrying capacity of structural body. Then for the third one is the support point addition method. Supporting the intermediate sections of the beams and other existing concrete members with new members or to reduce the span of the members. It is in order to restore or improve the load carrying capacity of a structure. Then the next one is the seismic isolation method. For the seismic isolation method, using seismic isolation bearings and the like to reduce the seismic energy applied to the structure in order to improve its various performance. It is during an earthquake. And then now in the monitor, you could see the samples of the retrofitting of structural body. So now let's go to foundation retrofitting. The first method for foundation retrofitting is the underground wall or beam addition method. So it is connecting the foundation with cast inside diaphragm walls and underground connecting beams to distribute stress and ensure the stability of the entire system. Then the second one naman is the pile footing addition construction method. When pile foundations are damaged or there is residual displacement, adding piles or footings to increase the load carrying capacity of the foundation. Then the next one is the foundation improvement method. It is improving the ground around the foundation with cement, to improve materials and to improve the ground bearing capacity and horizontal foundation resistance. It is also used to prevent excessive pore water pressure and liquefaction. Then the next one is the steel sheet pile covering construction method. Placing sheet piles around the periphery of the footings and binding them to the footings to improve the bearing capacity and horizontal resistance. Then the next one is the foundation compacting method. What is it? It is when insufficient foundation bearing capacity is a concern due to scoring or the like. Using concrete or the like to compact the ground around the foundation in order to restore bearing capacity. Then for the last one is the ground anchor method. So what is the ground anchor method or when it is applied? So it is applied when bridge abutments or move or tilt laterally as a result of an earthquake or etc. using ground anchors to stabilize the bridge abutments. So for the pictures or for the picture in this screen, you could see the foundation retrofitting. So now let's move to repair of cracks naman. So the first method is the crack fills method. So this method pours low viscosity resin and ultrafine cement into the cracks in existing concrete members to seal the cracks. Then for the next one is the fill method. Filling cracks, rock pockets, cavities, peeling, and other small-scale missing sections in existing concrete members with resin and mortar to repair sections. Then the third and the last one is the section repair method. So this method removes deteriorated or damaged portions of the existing concrete. Then for now, we're gonna watch a video of repairing of cracks. This is from Adhesives Technology Corporation. So, yun. The first step is cleaning, syempre. Lilinis muna yung cracks, all the debris, para kumapit yung ilalagay natin na epoxy or yun, adhesive. So, yan, in this video, una munang nilagay yung parang magic concrete dun sa external part siya ng crack. Then, ipa-flatten. Then, yung pinapakita niyan ay nozzle. Siya yung dun i-inject ngayon yung epoxy para pumasok siya dun sa loob ng ating crack. Inia-align siya ngayon sa mga cracks. Then, pag may align na siya, next naman ay yung pinaprepare na yung ating epoxy. For now, ina-inject na ngayon yung epoxy, then i-inject siya sa lahat ng nozzle na inilagay. Then, after na matuyo, ma-cure, yun, tatanggalin na yung mga nozzles, and then now, ayan, makikita mo, nilinis na siya, naging smooth na siya. So, makikita mo yung difference niya ng yung before and then the result of the process. Going to talk about the historical buildings naman. So, retrofitting historical buildings. So, buildings with historic values or regional cultural assets were preserving, right? So, the first method for historical building retrofitting is the no penetration building envelope. So this process does not require any destructive procedure, so the historic fabrication remains untouched. This approach is only applicable to very it's applicable to very limited cases since structural components are mostly either embedded in or covered by finishing. So the next one is the penetration without breakage. So the structure component subjected to retrofitting is accessible, and the retrofit process only requires drilling holes. So the next one is the breakage with repair. In many cases, some destructive procedures are required to access the structural component or to perform retrofit process. Then next is the replace. In cases structural components cannot be improved to meet retrofitting objectives, or the damage or deterioration could not be repaired, components are couldn't be repaired, so components are replaced. Then the last one is the rebuild. In cases a feasible retrofitting solution can't be found, the historic building is reconstructed partially or as whole na mismo. So for this, we have a video from UNTV, or the News and Rescue. So let's watch.
Do you remember this video that has gone viral on social media? This shows two condominium buildings swaying as a magnitude 6.1 earthquake struck Luzon in April. According to the Association of Structural Engineers in the Philippines, swaying skyscrapers during an earthquake is normal, as they are designed to be earthquake resilient. But what about old buildings in the country? According to Philippine Institute of Volcanology and Seismology, or PhilVox, Manila is one of the cities in the National Capital Region that would suffer the most in the aftermath of the so-called The Big One. Just like this building here in Binondo that has been standing for 100 years. According to a structural engineer, this can still be saved and turned into an earthquake-resilient building. Engineer Roel Ramirez says there are a lot of techniques to make buildings in the country earthquake-resilient or earthquake-proof, just like what they are doing in retrofitting this century-old Binondo building. He says viscoelastic dumpers will be installed as the building's supporting columns. Ramirez explains through this miniature dumper how the rubbers between the steels will absorb the earthquake shock instead of directly hitting the posts of the building.
This rubber will be used to absorb the earthquake energy pagka yung lindol gumalaw ng paganyan. Okay? Now, instead na yung column at yung beam ang mag-absorb ng earthquake energy, it is this rubber that will absorb the energy so that we can avoid damage in the column and the beam.
He emphasizes that old buildings would immediately collapse during strong earthquakes, such as the magnitude 7.2 Big One, if they were not installed with earthquake-proofing devices. Ramirez believes people should now focus on revisiting buildings and making them earthquake-proof. He argues, however, this is not stated in the National Building Code, which sets building standards in the country.
That's why everybody's telling us, come on, if there's an earthquake, takbo ka. O, diba? So bakit kailangan ganun? Why should not we design the building to protect us from hazard? Dapat lang naintindihan nila that with a new technology, hindi ito mahal. No, kasi minsan natatakot na kagad sa cost, hindi natatakot sa lindol. But after the lindol, nahihinayang sila sa building na nasira, no?
There are structures in the country, including a university, a hospital, and historical buildings that were undergoing earthquake proofing, he says.
So for the next one is the seismic retrofitting technique. There are many seismic retrofit techniques available depending upon the various types and conditions of structure. So for the first method is the structural level retrofit. So the structural level or structure level retrofit are commonly used to enhance the lateral resistance of existing structures, such retrofits for RC buildings include steel braces, post tension cables, infill walls, shear walls, masonry infills, and base isolators. So for the second one is the addition of RC structural walls. Adding structural walls is one of the most common structure level retrofitting methods to strengthen existing structures in order to reduce time and cost. Shotcrete or precast panels can be used. The overturning effects and base shear are concentrated at the stiffer infill locations. Then the next one is the use of steel bracing. Concentric or centric bracing schemes can be used in the selected base of an reinforced concrete frame to increase the lateral resistance of the structure. The advantage of this method is that an intervention of the foundation may not be required because steel bracings are usually installed between existing members. Then, for the next method is the seismic isolation. The objective of seismic isolation or the objective of this type of retrofit is to isolate the structure from ground motion during earthquake events. The bearings are installed between the superstructure and its foundations. Because most bearings have excellent energy dissipation characteristics, this technique is most effective for relatively stiff buildings with low rises and heavy loads. So, ngayon naman is the member level retrofit. And for our member level retrofit, ang ating method is the column jacketing. So, what's column jacketing? Column retrofitting is often critical to the seismic performance of a structure. To prevent the story mechanism during earthquakes, columns should never be the weakest component of the building structure. The response of a column in a building structure is controlled by its combined axial load, flexure, and shear. Therefore, column jacketing may be used to increase column shear and flexural strength so that columns are not damaged. Fiber reinforced polymer or the FRC material is used for jackets when retrofitting columns. For now, you could watch a clip of column jacketing. So yun, as we could see, reinforcing bars are installed around our column. Yun, so may mga holes na nilagay para doon ilalagay yung ating reinforcing bars, and then yung reinforcing bars natin ay lalagyan siya ng grout para mag-fix siya doon. Grout na serve as also concrete para maging kasinti ka siya ng concrete para kumapit yung ating reinforcing bar sa existing na beam or concrete. So merong hook na nakalagay siya, nakatusok siya doon sa ating column para siya yung pinaka-anchorage or pinakakapitan ng ating reinforcing bars doon sa ating column. The next one naman is the surface treatment. So, surface treatment is a common method which has largely developed through experience. Surface treatment incorporates different techniques such as ferrocement, reinforced plaster, and shotcrete. By nature, this treatment covers the masonry exterior and affects the architectural or historical appearance of the structure. So, for the first method, the ferrocement, ferrocement consists of closely spaced multiple layers of hardware mesh of fine rods with reinforcement ratio of 3 to 8% completely embedded in high-strength cement mortar layer. The mortar is thrown on through the mesh with covering thickness of 1 to 5 millimeters. The mechanical properties of ferrocement depend on mesh properties. So, ferrocement is ideal for low-cost housing since it's cheap and can be done with unskilled workers. The mesh helps to confine the masonry units after cracking and thus improves in-plane and elastic deformation capacity. For the next one is the reinforced plaster. A thin layer of cement plaster applied over high-strength steel reinforcement can be used for retrofitting. The steel can be arranged as diagonal bars or as a vertical horizontal mesh. Its strength depends on the strengthening layer thickness. And the cement mortar strength, the reinforcement quantity, and the means of its bonding with the retrofitted walls. Then the third one is the grout and epoxy injection. So grout injection is a popular strengthening technique as it does not alter the aesthetic and architectural features of the existing building. The main purpose of injections is to restore the original integrity of the retrofitted wall and to fill the voids and cracks which are present in the masonry due to of the slab can prevent punching shear failures. Then the next one is the FRP strengthening. Fiber reinforced polymer or the FRP typically consists of high tensile continuous fibers oriented in a desired direction in a specifically resin matrix. These continuous fibers are bonded to the external surface of the member to strengthen in the direction of the member or to be strengthened in the direction of tensile force or as confining reinforcement normal to its axis. So the FRP can enhance shear flexural compression capacity and ductility of the deficient fibers, or the deficient members. Glass fibers are most common types of fibers used as the majority of commercially available FRPs. FRP system is commonly used for structural applications. Then the next one is the slab column connections retrofits. In slab column connections retrofits, punching shear failure due to the transfer of unbalanced moments is the most critical type of structural damage. The retrofitting of slab column connections is beneficial for the prevention of punching shear failures, and much research into retrofitting slab column connections has been conducted and reported that adding concrete capitals or steels on both sides, um, yun. Next is the shotcrete. So, shotcrete overlays are sprayed onto the surface of a masonry wall over a mesh of reinforcing bars. The thickness of the shotcrete can be adapted to seismic demand. In general, the overlay thickness is at least 60 millimeters. In order to transfer shear across shotcrete masonry interface, shear dowels are fixed using epoxy or cement grout into holes drilled into the masonry wall. Retrofitting using shotcrete significantly increases the ultimate load of the retrofitted walls. This retrofitting technique dissipates high energy due to successive elongation and yield of reinforcement tension. So in this video, we could see the process of shotcreting. You can see the machine or the hose which pours the concrete to the our structure. So for the last part of this presentation ay ito naman yung parts ng bahay namin na kailangan ng retrofitting. So meron akong nilagay dyan na dalawang parts. First one is the column, and then the second one is our wall. Then so from the video, makikita natin yung wall, medyo malabo nga lang siya, pero could see the cracks sa wall, and kita natin na hindi na taas yung integrity niya. Then this the other view of the wall. It's the same wall pa naman. Yun, may mga lumalabas na bakal sa ating column. So for this column, ang isa sa retrofitting method na pwede natin gamitin dyan is the column jacketing, and the second one naman is the continuous fiber reinforced plate jacketing construction method. And then for the next part of our house that needs retrofitting is our wall. This in the kitchen part. So again, you could see in the video the cracks. So pwedeng gamitin na retrofitting technique or method dyan is the first one is the crack fill method or the injection of grout and epoxy. Then, the next one naman is the ferro cement. So, yun. This is the end of our of my presentation. Thank you.